Okay, I hope I'm audible to all students who are attending this particular lecture of mathematics. In this particular lecture, we are going to look at a very interesting topic in linear algebra, as all students can see, which is called matrices. So let's write the heading matrices. This is one of the important topics we cover up in our linear algebra course. Let's first of all look at what are exactly matrices. So students can write the definition. A matrix is simply a rectangular array of numbers. A matrix is simply a rectangular array of numbers considered as an entity. Considered as an entity. Okay, so when you write an array of numbers in a rectangular fashion, that's called a matrix. Okay, I can write with m rows, and n columns, with m rows and n columns, and m cross n matrix, and m cross n matrix is given by the matrix A. Now all students can see how I'm going to write the elements of this matrix. So A11 is the element in the first row and first column. So I'm writing the elements of the first row. A12 is the element in the first row, but second column. A13 is the element in the first row, but third column. And I can stretch it on to how many such columns do we have? We have n such columns. So A1n is going to be the matrix, is going to be the element in the first row, nth column. Similarly, A21 is the element in the second row, first column. A22 is the element in the second row and second column. And then I can stretch it on to A2n, which is the element in the second row, nth column. I can stretch it towards how many rows? We have m such rows. So I can stretch it on to AM1, which is the element in the mth row, first column. AM2 is the element in the mth row, but second column. And then similarly, I can stretch it on to AMN, which is the element in the mth row and nth column. So using red color, students can see that this is the first row, this is the second row, dot, 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 this is the mth row. So I can write first row, second row, and this is my mth row. Using the blue color, students can see that this is the first column, this is the second column, and I can stretch it on to saying that this is the nth column. So I can say that this is a general M cross N matrix, which all students can see on their screens. Now, how do I write it in a concise form? So I can write that in particular, I can write the matrix A as Aij M cross N, where Aij is the element. Aij is the element in the ith row. It's the element in the ith row and the jth column. So this is how I can write the matrix in a concise form. Aij is the general element lying in the ith row and the jth column. Okay, so let's look at some examples of matrices. So if I erase all this off, the students can now write examples of matrices. Examples of matrices. So let's look at these examples. So suppose I take one matrix, let's say A, which is as follows: 3, -2, 5, and 8. Now students can clearly see it's a 2 cross 2 matrix. It has 2 rows, row 1, row 2. It has 2 columns, column 1, column 2. Similarly, if I take another matrix B, which is, let's say, 1, 2, 3, 4, 5, 6. I have randomly chosen the entries. If you look at the order of this matrix, it contains 3 rows, 1, 2, and 3, and only 2 columns. The order of this matrix is 3 cross 2. Okay, so I hope all students attending this lecture have understood how we work out the order of the matrix. You simply count the number of rows, you simply count the number of columns. The order of the matrix is nothing but the number of rows cross the number of columns. Okay, so now all students can also write a note. Let's understand what is meant by a row vector and a column vector. So let's write the first heading, row vector. So I can write that a matrix with only one row, a matrix with only one row is called a row vector. A matrix with only one row is called a row vector. Okay, for example, let's talk about a matrix A, which is like this: 1, 2, let's say 5. Randomly, I can choose any number. So 1, 2, 5, and 9 are the entries. Students can clearly see that there is only one row. But how many columns are there? 1, 2, 3, 4. So the order of this matrix is 1 cross 4. You can clearly see it's a row vector. Why? Because this matrix has only one row. Let's look at what is meant by a column vector. Now, if students have understood what's a row vector, then a column vector becomes even more easy to understand. So I can write a matrix with only one column. A matrix with only one column is called a column vector. A matrix with only one column is called a column vector. For example, let's talk about a matrix B, which is 1, 3, 5, 7. It's a matrix consisting of all odd natural numbers between 1 and 7, including 1 and 7. So the order of this matrix, as you can see, it has only one column, but it has 4 rows. It's a 4 cross 1 matrix. So I quickly repeat, a row vector is that vector which is consisting of only one row. So that matrix which has only one row. A column vector is that matrix which has only one column. Okay, now let us look at a practice question on constructing a matrix when we are given the general order. So let's look at a practice question on constructing a matrix when the general order, when the general form is given. Okay, so suppose I look at one question where suppose I'm given construct a 4 cross 3 matrix. That means construct a matrix with 4 rows and 3 columns. If the matrix A, whose general form is Aij4, 3, 4 cross 3. So A, capital A is equal to Aij, which is a 4 cross 3 matrix where we are given that the general form Aij is equal to 2i minus j. So in order to solve a problem like this, first of all, students should write the matrix in the expanded form. So a 4 cross 3 matrix would mean 4 rows and 3 columns. So it's going to look like this. A11, A12. How many such columns are there? 3 columns. So I'm going to stop at A13 because only 3 columns are there. A21, A22, A23. These are the elements of the second row. A31, A32, A33. These are the elements of the third row. And how many such rows we have? 4 rows. So I'm now writing the elements of the last row, A41, A42, A43. This is the form of the matrix A, which is a 4 cross 3 matrix. Clearly, it contains 4 rows and it contains 3 columns. Now we are given the general form. Aij is 2i minus j. So can I quickly calculate what will A11 be? Put I and j both as 1. So I get 2 into 1 minus 1, which is 2 minus 1, which is 1. What will A12 be? Put I as 1, j as 2. So 2 into 1 minus 2, which is 2 minus 2, which is 0. What will A13 be? Put I as 1, j as 3. 2 into 1 minus 3, which is 2 minus 3, which is minus 1. What is A21? Put I as 2, j as 1. 2 into 2 minus 1, which is 4 minus 1, which is 3. What will A22 be? Put I as 2 and j also as 2. So 2 into 2 minus 2, which is 4 minus 2, which is 2. What will A23 be? Put I as 2, j as 3. So 2 into 2 minus 3, which is 4 minus 3, which is 1. What will A31 be? Put I as 3, j as 1. So 2 into 3 minus 1, which is 6 minus 1, which is 5. A32 will be put I as 3, j as 2. So this is going to be 6 minus 2, which is 4. A33 will be put I as 3 and j also as 3. So it's going to be 6 minus 3, which is 3. So starting from here, we have worked out all this. I still have to work out the last row. So A41 is going to be put I as 4, j as 1. So it's 8 minus 1, which is 7. Okay. Then we have A42. Put I as 4, j as 2. So it's going to be 6. And then we have the last entry, A43, which is put I as 4 and j as 3. So this is going to be 5. So we have calculated all the entries of this matrix, and all what it remains is for us to now write the matrix. A11 is 1. A12 is 0. A13 is minus 1. A21 is 3. A22 is 2. A23 is 1. A31 is 5. A32 is 4. A33 is 3. A41 is 7. A42 is 6. And A43 is 5. So students can clearly see this is my answer for the matrix A, which is a 4 cross 3 matrix. You can clearly see the matrix has 4 rows, which we have calculated, and the 3 columns, which we have calculated. Okay, so I stop now in this particular lecture. The objective of this lecture was to introduce the concept of matrices, look at the general form of a matrix, learn about what is meant by a row vector and a column vector, and look at a numerical example where, given the general form, we construct a matrix of a given order. So any doubts in this particular lecture, students can now unmute their mic and ask. I hope all students have enjoyed this particular lecture. This is where I stop in this particular lecture.